Hello, class. I am your professor today, Tom Hanksbot. I am completely generated by machine learning. In traditional natural language processing, we represent words as discrete symbols, such as hotel, conference, and motel. This is often referred to as a localist representation, in which each word is represented by its own unique symbol. We can represent these symbols by one-hot vectors. For example, motel and hotel can be represented as shown above. The dimension of the vector is equal to the number of words in the vocabulary, which can sometimes be in the hundreds of thousands. The problem with this discrete symbol approach is that it doesn't capture the notion of similarity. Using our example above, if a user searches for Seattle Motel, we would like to match documents containing Seattle Hotel, but the vectors for motel and hotel are orthogonal. There is no natural notion of similarity for one-hot vectors. One solution would be to try to rely on WordNet's list of synonyms to get similarity, but this is known to fail badly due to incompleteness. Instead, we should try to learn to encode similarity in the vectors themselves. In the context of NLP, another way to represent words is by their context. That is, the words that appear close by. This is a concept known as distributional semantics, which states that a word's meaning is given by the words that frequently appear close by. This idea was first proposed by J.R. Firth in 1957 and has become one of the most successful ideas in modern statistical NLP. When a word W appears in a text, its context is the set of words that appear nearby within a fixed size window. We can use this context to build up a representation of W. Finally, we'll build a dense vector for each word, which is chosen to be similar to vectors of words that appear in similar contexts. The similarity is measured as the vector dot product. These word vectors are also called word embeddings or neural word representations, and they are a distributed representation. This representation allows us to capture the meaning of words in a more nuanced way than simply relying on discrete symbols. By representing words as vectors, we can capture the semantic similarity between words and use it to perform many NLP tasks.